Next piece I'm going to attack is the grinder body itself. The main frame casting is really clean. The alignment's really good, relatively good. I would say above average. Going to file off all the flash lines here. Not going to bore you with hours of running a file over something, but I will cut all these parting lines off and blast it and make it look brand new. And we'll come back and show you what it looks like just before I start milling on it. Let's do it. Nice little part. And after minimal filing and some blasting, this is what the casting can look like. All the parting lines are gone. All the rough edges are taken off, and I do believe that all these other surfaces get machined, so I'm not going to mess with it any further. At least that's the plan. Now I got to figure out how to hold this thing so we can get a good starting position on the bottom. And I will probably use the center and the base to clamp it for the vertical operations like that. Let's get started. After staring at this piece for a while, it became abundantly clear that this is probably the best way to start. I'm going to use the platforms that the tool supports will bolt to as my horizontal reference, and the bosses that hold the spindle for the vertical parallel reference, and I think everything's going to work out quite well. I'm going to take a dust cut on the bottom of this, and then we're going to take some preliminary measurements and see how true everything is. Hopefully it is as I expect. With the part in a favorable orientation, I'm going to center it up and put the mounting holes in now while it is here. Why not? Let's do it. I've elected to hold the grinder casting itself this way on my little fixture plate oriented to the x-axis. The bosses on the top are slightly off center, so get it visually aligned and then bring it in dimensionally. This is going to be a relatively easy do. Going to cut the top off of these, put a couple of oiler holes in. I will do the oiler holes probably after I do the spindle, only because I don't like a precision hole going across an interruption. You don't need any influence. I want it to be as straight as possible. Going to put the mounting holes in here for the tool supports. Clean it off, open up the center. I'm going to go a little bit wider on the center because I do plan to put bushings on either end of the pulley that goes in the center, so as it rots back and forth, it hits the bushings and not the casting. Should be pretty straightforward. Let's do it. In an attempt to keep the final product symmetrical, I've got the end mill oriented to the x-axis of the machine. I'm going to walk the end mill back and forth, picking up on the inside corners of each of these sides. I will zero out my digital on one, take the reading to the other one, split the difference, and I'll have the center. That way, if these bosses are different heights, when I walk equally in both directions, I should bring them in visually pleasing to the eye and somewhat on center. So that's the plan. Let's do that. All right, the tool is sufficiently on center. I'm going to walk it back and forth to obtain the gap plus the thickness of the shims I'm going to put on either side of the pulley. That's a great camera angle, but boy, that is right in my way. Let's see if we can do it. All right, visually that's an equal shift, but visually looking at the casting, I'm not pleased with that. I'm going to say that the left is a little bit more pronounced than the right. I'm going to center the tool another, let's say 5 thousandths, favoring this side. That would be a 10th difference from where it is right now. Re-zero the digital. Try it again. That would be a good reason not to go to your finished dimension initially. Clean it up, check it, adjust as necessary, take a little bit more. That little feature right there is so that the tool support sits on a true surface. And be careful when you put this in that you don't hit the face of that. The dimension is really, it's quite close, so be careful. So I'm drill and tap some holes in this and call this orientation done. One thing that I like to do as I'm working is evaluate the way I'm working and the way I'm holding my piece for the most efficiency. If I was doing a bunch of these, well, even for one, as a matter of fact, holding it in this orientation is good because I like working with the x-axis for visibility. It's also good for camera angle. But as far as efficiency is concerned, if you were to rotate this part 90 degrees and have the casting running along the y-axis, after all these features were put in, easily put in, just using different axes for the machine movements, of course, you could just simply flip this fixture, stand it straight up, and be in the correct orientation for the spindle bore that needs to go through these bosses. So rotate the part 90 degrees, do it along the y-axis, and then just rotate the fixture 90 degrees and pop that hole in there. Hindsight is 20/20, but it'll get done either way. Using a gauge pin, just about the same size as the boss on the casting. Visually align the pin to the casting. Zero out everything. Get ready to drill it. And yes, it is repositioned in the machine. And now I can just go back in there and drill the 1/16 oil holes in the top when I'm done with the cross hole. Let's do it. I think it's an extremely safe bet that I'm going to be putting oil cups or at least screws in these holes to block the passageways. So I'm going to drill and tap it for a 256 imperial thread. Okay, here's a little shop gem for you. See the very tip of this tap? The very tip of that does absolutely nothing. So basically you can sand off or grind off the end of a tap if you're not going to put it back in the machine and try to do anything fancy with it grinding wise. Cut it back and maintain the tip of the tap to a little smaller than the tap drill size so you still have a lead. I need a little bit more room on this tap so that I can be feeling good about how far it went in, so I'm going to make a flat on the front of this. Just to end it right where it's pointed, spade type. Extremely minimal, still within the diameter for the tap drill, so it does have a lead. Let's see how we did. Nope, still goes in. Re-engaging a thread, always turn it backwards till it clicks. There's the click. And go ahead and feed it in. Just a little bit extra does the job. Here's a good look at the part prior to being fed into the blaster. It is all deburred. I block all critical surfaces with either rubber plugs or wood dowels. Wood is good because you can screw it right in, and after blasting you can screw it right out. That helps a lot. Let's blast it, take a look after the fact. Following the blasting, everything is returned to what it looks like a cast surface. Do this on extremely low pressure. You will distort this piece if you blast it too hard. I use about 30 pounds of pressure. The threaded plugs will come out relatively easy. The one in the center, work it back and forth, use air. Do not be aggressive with any plugs after blasting. It's only going to scar up critical surfaces. Be very careful. If you can, mask them. The drive pulley for this little grinder is like a small barrel. It's 5/16 of an inch long. That's about 9 millimeters. It's about 5/16 in diameter as well, with an 1.5 inch radius on it. So it's a very large radius. I'm going to show you how to center up a radius tool. I'm not going to bore you with the drilling and reaming of this component. You've seen that 100 times. But I'm going to show you a quick way, maybe an easier way to align a round tool, concave form tool on your part. First thing I'm going to do is face this part off, establish a 0, and then I'm going to undercut the diameter to the finished length of the part that I'm going to make. This particular protrusion on the end is now a finished length. Using the form tool required for that feature. Make sure that you have sharp corners on both of these. That's very important. When you line your tool up, and if you have to try 2 or 3 times to get this right, there's no shame in that, because this is not an easy thing to do by eye unless you have an optical comparator and you know exactly what this tool looks like. What you're looking for is both edges, both of these sharp corners here to clean up basically at the same time, and for the radius to migrate towards center evenly as you feed the tool in. And if my numbers are correct, this is where I need to be, right here. Ever so slightly, you can see a witness mark showing up on the OD of this part. Realistically, this tool is making contact here before it's making here. That's why that little shiny spot is wider. I can shift the tool. I'm going to go about 1/1000th to the left and finish this dome. Having a leftover raw stock remnant is okay. It tells you that the diameter of the part is probably right where you want it. So don't erase the entire diameter if it's a tight diameter dimension. Going to drill it, ream it, deburr it, take it over to the mill, and we're going to put a threaded hole right in the center grub screw. Positioned in a V block and centered up conventionally. Use an edge finder on either side, sweep either side, edge finder on the front to find the very dead center of this. We're going to put a 172 set screw in there and a corresponding flat on the spindle so that you can break it down without galling up the inside of this particular pulley. Can't keep the wheels on unless you have the nuts for the end of the main spindle. One is a left hand, one is a right hand. These are 256 threads, approximately 2.2 millimeters in diameter. Now, I've always said the best way to remove a burr is to not make it in the first place. If you are cutting brass and it is leaving a ragged edge, sharpen your tools. It's a lot easier to leave a clean edge than it is to deburr a part. And a 256 left hand for the opposite end. Stick it back in the collet champ for the opposite side. These are done. Next piece in line is the spindle. Got to put a 256 thread on one side, right hand, 256 thread on the other side, left hand. Now this is called out in the kit as a 172. This is my choice to upsize this thread. I just want a little bit bigger threads on either end of this thing. Okay. Same exact thread. One's a left hand, one's a right hand. Left side, left hand, right side, right hand. Going to do them exactly the same way. I'm going to thread from the collet out. The right hand will be an inverted tool, threading out. The left hand will be conventionally positioned upright tool, threading out. It's going to look a whole lot different in a couple minutes. Let's do it. Threading operation, I'm going to do the left hand thread first. The machine is going to be running forward, standard rotation. The carriage is going to be moving from the collet out. So it's going to be moving from left to right, and the feed mechanism, the feed drive levers are going to be set in reverse. If you're not sure exactly what that means or how that functions, back your carriage away from your collet or your chuck before you engage the threading lever, and you'll see exactly what I'm talking about. So with the machine spinning forward, with the tool upright, threading from left to right, you're going to have a left-hand thread. And 56 threads per inch. This is about a 2.1 millimeter diameter final result. That was a 570 RPM cut. I'm about 9 thousandths deep into that material. I'm going to get the left-hand nut and use that as a gauge. I don't usually do that, but this is a controlled build, so I'm going to do it here. The easiest way I found today to keep track of my nuts is to leave them on the tap. It's easier to identify the tap than it is to identify the nut. So the nuts are securely on the tap. I'm just going to look at the marking on the tap, take the nut off, and try it. Beauty. All right. There's a 256 thread, stainless, or that's a cold roll shaft, brass nut. This would be the left-hand side of the grinder when we set it up. Rotation of the grinder keeps the nuts tight. Let's clean that up with a wire brush, flip it around, do the conventional thread on the other side, and take a look at it. The setup for the opposite end of the spindle is a right-hand thread, and anybody that watches this channel knows I'll do a right-hand thread with an inverted tool. This is a left-hand tool holder. I'm threading left to right. Make sure you return the machine to all the standard settings or you're going to crash. Carriage has got to come away when you engage it. If everything went well with the spindle, this is what it should look like. Left-hand thread on one side, right-hand thread on the other side. Simple turn journals on the ends. And I put a small flat in the center to receive the grub screw, set screw, from the little barrel pulley that goes in between the uprights. Relatively straightforward. More setup and headache initially than actual machining time. Machining was relatively easy. But keeping track of everything, getting all the tools together, that's going to slow you down a little bit. Time well spent. One step closer.